All right, welcome. We're going to go over another important type of aqueous reactions, which are acid-base reactions. We're going to spend a lot of time on these later in the semester, but I want to give a basic introduction now because it's a very important type reaction. And this is probably going to review for a lot, but let's go over some of the objectives, learning objectives here. So all right, so we want to be able to describe the difference between weak and strong acids and identify strong acids, describe the difference between weak bases and strong bases, and identify strong bases, and write net ionic equations for neutralization reactions. So acids. So on a substance that dissociates in or reacts with water to form H+ ions, more precisely hydronium ions, is one very common definition of acids and bases. And we'll get into a little more useful definition later on. But commonly, hydrochloric acid says it right on the tin, hydrochloric acid. Hydrochloric acid functions as an acid by donating the hydrogen. The covalent bond that occurs there breaks, and it covalently bonds to H2O to form H3O+. So one important thing, sometimes we'll talk shorthand about there being H+ or a concentration of H+ in a solution. H+ is virtually never alone in a solution. It would immediately react to another molecule nearby. When we talk about that, what we generally mean is that there's H3O+ in the solution. And that is the dominant species in an acidic solution, where in this case, the proton gets donated from the chlorine to H3O+. Okay, so strong acids versus weak acids. So we talked about strong and weak electrolytes. Strong acids are strong electrolytes. They essentially 100% react. The HCl reacts to form H3O+. So the neutral HCl dissolves and produces 2 ions per molecule, 1 chloride ion and 1 hydronium ion. A weak acid, on the other hand, only partially disassociates to form H3O+. Maybe, and depending on how weak it is, somewhere between 5% and 0.01% disassociates to form H3O+ and an anion of whatever the weak acid was, acetic acid and an acetate ion. And so you get some H+, but not as much as you get if it entirely disassociated. So those are the strong acids and the weak acids. Brief clicker question just to make sure this is burned into your brain. The following represents aqueous solutions of 3 acids. Which of the 3 is the weakest acid? So I'll pause, let you think about that. Notice the legend. HA would be the green and white molecules. H3O+ is red and white, and A- is just the green alone, and neutral water is not depicted. All right, coming back. So the weakest acid would be the one that produces the least hydronium. So that would be C. That is the weakest acid here. There's only, no, sorry, back. I was not paying attention. The weakest acid is the one that produces the least hydronium, which is A. There we go. I was not looking in the right place. So that is the weakest acid. It produces the least hydronium. It disassociates the least. HC is not particularly strong. HY is a strong acid. You notice that all of the HAs have lost their hydrogen and donated it to water to produce hydronium. That's strong. The weakest one is the HX, or option A. Okay. Polyprotic acids are important. Some acids can donate more than 1 H+. For example, carbonic acid, the first dissociation, the first H+ coming off, you'd get HCO3- plus H+, really hydronium, but sometimes we use H+ as a shorthand. The second dissociation would leave a carbonate ion. So the HCO3- is a bicarbonate ion. Here you leave why it's bi when there's 1 hydrogen. I don't know. Some of the names are weird. But H3O- disassociates to produce the carbonate ion and H+. Phosphoric acid is another example. It actually has 3 hydrogens that can be donated. H2SO4 is a unique case because both the first and the second dissociation are quite strong. The first one is extremely strong, and the second one kind of qualifies as a weak acid, but it's about the strongest weak acid you can get. like maybe 30% disassociates. Whereas carbonic acid, the first one is weak-ish, and the second one is quite weak. So phosphoric acid, the first one, it's fairly strong acid. The second one, not so much, and the third one, not at all. We'll talk a lot more about that later in the semester. The point is that if you have a complete reaction, you actually do, phosphoric acid actually does get rid of all three hydrogens.